stereo window. We add that stereo viewport to the stereo window. And here what we're doing is we're telling the viewport, you're just going to track the window size, because it is possible to set different dimensions on multiple viewports. But in our simple case here, we're just telling the viewport, go ahead and take all of your position and size information from the actual stereo window. For our objects in our SDK, they're reference counted so that we know when to actually delete them. In this case, in this sample code, we're not going to hang on to the stereo viewport object anymore because we've actually added it to the stereo window. So we're going to remove our local reference to that object, and that makes sure that it cleans up when things actually need to get cleaned up. So that takes care of the sort of bookkeeping pieces needed to actually enable a stereo application. This slide here, if you saw the first webinar, should look familiar. This is when we were talking about the overall structure of the rendering loop that needs to happen when you're actually rendering a stereo image. And again, just for review, as you go through this loop, you're going to clear the back buffers. You're going to position the left camera and give it its appropriate projection matrix. Then you're going to render the scene. You're going to position your right camera, and then you're going to render that scene. And then you'll do a swap buffer. And the swap buffer command basically tells it, take the two things in the back buffers and make them into the front buffers. And that's what gives you the stereo left and right pairs. And then that continually gets refreshed out to the display via the back-end circuitry. So now let's look at what that starts to look like from a coding perspective. Again, using OpenGL,